Hey guys, so these are your notes on energy bar graphs. All right, bar graphs can be used to represent how much kinetic energy, gravitational potential energy, and total energy you have in a roller coaster at different locations. So you can see I drew this coaster here, labeled with 5 different locations, strategically placed to see how the bars' heights are different at each location. So one thing we'll just kind of remember with an energy bar graph is that the total energy remains the same. Okay, so you might want to make a note of that. I'll write it here. Uh, ET is constant. All right, so the height of the ET bar is constant. Now, the lower the coaster goes, the faster it goes. Therefore, it has more kinetic energy when it gets to lower locations, okay? Because when you drop the coaster, it goes faster, gains kinetic energy. So we think when we look at B is the lowest, it probably has the most kinetic energy. E is probably the second lowest, has a lot of kinetic energy. But, A and D have very little kinetic energy because they're pretty high up, all right? The higher the coaster is, that means it has more, like here, gravitational potential energy. All right. So A and D would have a lot of GPE. Okay. Um, Another rule with energy bar graphs is that the height of the bars should add to the total energy. Right? Why should the height of the bars add to the height of the total energy? So height of GPE and KE bars add to height of total energy bar, okay? Because when you add those two together for a coaster, GP and KE, what do you get? You get your total energy, right? So the same thing occurs for their heights. So let's look at the bar graphs we drew here for each location. Let's start with A, where the coaster starts at rest. What that means is it has no kinetic energy when it starts at rest. So I drew in red, it's going to be our kinetic, all right? And I just drew a line there saying at 0, Then I drew a 4-inch tall bar there for GPE, saying we have a height of 50 meters, so we have a bunch of GPE. Just not totally to scale here with numbers or calculations, just conceptually. That also means that when you add these two bars together, 0 height and 4 inches of height, you get another 4-inch high bar for total energy. So that means that throughout the coaster, our total energy should be a 4-inch high bar. As you can see, the purple on the right, the purple bar for each location, A, B, C, D, and E, is a 4-inch high bar. All right, and you could use a ruler to make that for yourself on your paper. Now in letter B, as it speeds up, it loses all its GPE, and at the bottom its GPE is 0. Right? So we drew, again, we could do it here. I'm just going to use blue, say, oh, there is no GPE there. But the kinetic energy is at a max there. So kinetic energy, 4-inch high bar, gravitational, nothing. Gets you, add them together, you get another total bar 4 inches high, right? Now for letter C. C is halfway back up to that 50-meter height. Halfway is an important location because it means that the energy is split 50-50. All right? Half GPE, half kinetic energy. So we start at a 50-meter height, at a 25-meter height, then we have half and half, split 50-50, two 2-inch high bars and a 4-inch high bar for total. Going on to letter D. Letter D is a 40-meter high height. Okay, so that's pretty close to the top, which is 50 meters high. Because it's pretty close to its original height, that means it has a lot of GPE up here. So 25, it had some GPE, right? But 40, it's going to have more GPE because it's above halfway up. So the GPE bar, if it's above halfway up, I can write that down, above halfway up. This is halfway down, right? This is the bottom. top, right? You can kind of mark those for yourself. But above halfway up means that's not split evenly. It means that GPE is greater than kinetic energy. Do you still have kinetic energy? Yeah, you're still moving there, so you still have kinetic energy. Not that much, though. Letter E is at a location that is below halfway down. So 25 is halfway down, 10 meters is below that. So that means it has even more kinetic energy than gravitational potential energy. Right? And we represent that here with a high kinetic bar, 3 inches high, a 1 inch high GPE bar, and a 4 inch high total energy bar. So below halfway down, what does that mean? That means KE, in this case, is greater than GPE, right? Above halfway down or halfway up, that means GPE is greater than KE, right? And halfway down means GPE is equal to KE, right? Bottom, only KE. Top, only GPE.